Hi again, everyone. This is Miss Bowen from PEP Practice. Hi again, everyone. This is Miss Bowen from PEP Practice. We are looking at the grade 5 mathematics sample item that the ministry has provided. It is the 2019 past paper. Again, the only performance task that was administered to the grade 5 students was in 2019. Since then, there has not been another administration of the grade 5 performance task until this year. So these tasks will be administered the 8th and the 9th of June. And yes, it's next week. I'm going to be going through the teachers' activities as well as these past papers, and that should provide enough resource additional to what your teachers are doing at your individual schools to aid in your preparation for your examination. So we're going to go to the questions of this paper. So for each performance task, there's an introduction to the task, and that's what we're going to be reading. Firstly, there's also instructions as to what to do for each question. The title of this performance task is Your Class Party. This task has 3 parts. We should read the information in each part carefully and answer all the questions in part 1, 2, and 3. The description of the task reads, your class is planning a class party. You are to assist the teacher with purchasing food and drinks for the party. After completing a survey for your classmates, you would discover that most students in your class prefer to have pizza and juice. You are preparing for all 42 students in your class. Notice this information is in bold and you must pay close attention to that detail. Each student will be served at least 1 slice of pizza and 1 cup filled with juice. Your task is to determine the number of pizzas needed, the amount of juice needed, and the total cost of the pizza and juice. This performance task is from the number strand. The objective of this problem here is to see how well you're able to perform operation on fractional numbers. In this question, you're going to be required to use your knowledge of fraction to solve a real-life mathematical problem, which involves determining the fraction of the class that the pizza of different sizes will serve. So part 1, the number of pizzas needed, says that Amazing Pizza sells pizzas of 4 different sizes: small, medium, large, and extra large. The table below shows the total number of slices per pizza and the fraction of the class 1 pizza serves. And we can see that from the column titles. Question 1 reads, complete the table to show the fraction of the class each pizza serves. So we have one of the rows already completed for us. The size of the pizzas are small, medium, large, and extra large. The row with the small pizza was completed. So the number of slices in each pizza for small, you have 6 slices, medium, 8 slices, large, 10 slices, and for extra large, we have 12 slices of pizza. The fraction of the class that the small pizza will serve is 1/7. But how did they get 1/7? Before we even move on to solving the medium, large, and extra large rows, we're going to try to figure out how did they get this 1/7. So we can assume that this 1/7 was arrived at because in our description, we learned that there were 42 students in the class. So that's the whole, and we'll put 42 here. And if the number of slices is 6 slices, then we'll put 6/42. Now we will further reduce this fraction. We can divide, technically what we're doing is dividing the numerator and the denominator by a factor of each of these numbers. So the number that can go into both 6 and 42 without leaving a remainder is 6. So we can cross it out, or we can divide it by, put the division sign and put the 6 there. We're going to cross it out. So 6 into 6 goes 1 time. And 6 into 42 goes 7 times without leaving a remainder. And that's how they got the 1/7. Or the 1/7. So now we can use that same method to find the fraction of the class the pizza will serve for the remaining size. So we can add 42 for all of the denominators since we know that's what the whole is. And because it's a fraction, you can do it one by one, or you can just do it like how I am doing it now. This is easier for me. So we know that the number of slices for the medium pizza is 8. The number of slices for the large pizza is 10. The number of slices for the extra large pizza is 12. Leaving it as is okay. You can also further reduce it, and that's what we're going to do. So we're going to find a number that can go into both 8 and 42. So 8 cannot go into 42 without leaving a remainder. So we're not going to be using 8. 4 cannot go into 42 without leaving a remainder. So we cannot use 4 either. Those are all factors of 8. So we can use 2. 2 into 8, 4 times 2 into 42, 21. As I said, we can leave it as is, or we can do the reduction here. 2 into 10, 5. And you only need one of these fractions. So either you cancel this out and put this new fraction here, or you can leave it as is. I'm just going to cancel and reduce, seeing as I like my fraction in the lowest form. And I'm going to use just 2 as the common factor to reduce them. I could have used 6 here because we know 6 goes into 42. So I can say 6 into 12, 2. And 6 into 42 is 7. So I can have 2 over 7 here. And that's it basically. As I said, as they are before, with the 8 over 42, 10 over 42, 12 over 42, they are correct. I just did a further reduction. All right. So now let's move on to question number 2. It says, for each pizza size, determine the number of pizzas needed to serve all the students in the class. Each student will receive 1 slice of pizza. It says you should indicate your answer by shading 1 circle in each row. So by looking at it, and looking at my responses here, I could simply do a multiplication, right? And I'm going to show you that afterwards. But I don't really like to do the multiplication because it does not give me a keen insight to problem solving. Neither does it help me to utilize the planning process of my problem solving process or problem solving approach. So I'm going to go to the whiteboard. I'm going to be sharing my whiteboard and I'm going to be doing some proper problem solving. So my first step in the problem solving process was to understand the problem, and that's what I read and did. If you are reading the problem and you don't quite understand the problem, you should read it over again. So I know that based on my recollection of reading it, it is asking me how much pizza for each of the sizes of pizza, how much can serve for the entire class, or how much pizza, in layman terms, would I need to buy of each of those sizes of pizza to serve for the entire class. So, as I said, I'm going to be using my problem solving strategies, which is making a plan. In this case, I'm going to use diagrams. And students, even though we're getting much older, our drawing of diagrams is still relevant. It's not only structured for kindergarten. So the one that I'm going to be looking at, I'm going to use a description for all of my diagrams. So I'm going to say that the small pizza can serve. You can use any title for your diagram. So you can say the small pizza can serve whatever you want to call it. Or you can say that dash, and this is the figure that we're going to put afterwards. We need dash small pizzas to serve 42 students. You can either do it like that and then put the dash afterwards. I'm going to go ahead and draw my pizzas. Please bear with me if they're not drawn appropriately. So that's one of my pizzas. I'm going to draw 2 starting because I'm not sure how much I'll need initially. I'm going to just start with 2 and then I'll work my way up. So let me start cutting my pizzas. I'm going to use the drawing tool. Should I just get it very neat, twisty? line 2. All right, so that's 1, 2 slice, cut it up again, 4 slice, 4 slices, 2 slices, 4 slices. I'm gonna cut it again here, and that's 6 slices of pizza. 2 slices, 4 slices, 6 slices. So 2 pizzas, and I'll do this. I'll write these small statements for as long as I go along the working out or the drawing of the diagram, just so I can be keeping track of what I'm doing. So I'm gonna say 2 pizzas or 2 small small pizzas. My title. 2 small pizzas will serve 12 students. And that's simply because I know that this has 6 slices and this has 6 slices. So this is small pizzas. Let me put this here. 2 small pizzas will serve 12 students. So 2 small pizzas will serve 12 students. Let me go ahead and do some more pizzas. That's 3 pizzas. And this is what I was explaining. I could just simply multiply or divide to get my answer. So I know that there's 42 students, and I know that each pizza has 6 slices. So I could simply divide 6 into 42 and I'd get the amount of pizzas I need. I don't want to do it that right way, because as I said, when we do it like that, we don't really utilize our problem solving process. I'm just gonna draw pieces here. I just draw 3 other pieces just to get my working out going, or get my diagrams going. Because I have an idea of how many pizzas I would need. So that's another 6 slices of pizza. Let's go again. Another 6 slices. Another 6 slices. And then I can pause to write another statement. So those are 5 small pizzas, and I can say that now. If 2 small pizzas give me 12 slices, 3 16 slices, because I know my multiplication table, I can just count 12, 11, 13, 14, 15, 16, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, 24, 25, 26, 27, 28, 29, 30. So 5 small pizzas. And we could do it for 1, 2, 3. I'm just shortening the statements. 5 small pizzas will serve 30 students. So again, if I'm paying close attention, I can already see how much pizzas will serve 42 students, because I could add this 30 and this 12, right? to get to 42, and I can add this 5 and this 2, and to say that there would be 7 pizzas for 42 students. But I really want to do the elaborate way. Yes, problem solving with the planning process of drawing my diagrams. I can really never go wrong when I draw my diagrams. I'm just gonna just put them anywhere I feel like here. Let me get my slices in. So I'm gonna put 6 more slices there, and I can just count them while I'm doing them. 32, 34, 36. 6 pizza will give me 36 slices. 37, 38, 39, 40, 41, 42. So 7 small pizzas, 7 small pizzas will serve 42. I have not made an error thus far. And that's why I really appreciate the planning phase of my problem solving process, where I really draw out my diagram and see what is taking place, and I really will not have an issue where that is concerned. All right, and if I wanted to, I could just call them 1, 2 slices and count all the way to 42, and I will be still correct. Realize I didn't do any form of working out per se, and that's what the planning process is about, because you don't need to do any working out. It's a far sophisticated way of solving your problem. Or we can say that we've always been doing this, but we have neglected it to some extent, where we don't go back to the basic of our problem solving process, where we understand the problem, we have decided to use a diagram, we're carrying out the plan, which is using the diagram, and then we look back over to see if our problem is correct, and it is. So we can say that this is 100% correct. Let me go back to my booklet to shade in my response. So it will take 7 small pizzas to serve the 42 students in the class. All right. And I'm gonna do that for all of the sizes of pizza. So I'm gonna go back to my whiteboard and work out for the medium pizza. I'm gonna clear everything here. Save first, and then clear all the drawings. I'm gonna give it another title, the medium pizzas. And I'm gonna put my ending statement there. It will take, put my dash there, medium pizzas to serve the class. I could have moved it away, but it's okay. All right, now onto my medium pizzas. So I know that my medium pizzas has 8 slices. Probably need to make, no, it's okay. So that's 8. Yeah, I probably need to get it a little bit smaller. 8, 16. I'm just gonna do a rough count, 24, because I know my multiplication table. As I said, you can work this out without using these diagrams. it defeats the problem solving process, however. So let's get 8 slices in. 1, 2, 3, 4, 5, 6. Excuse me, 8. We always count to check. 1, 2, 3, 4, and 1, 2, 3, 4, 8 slices. 1, 2, 3, 4, 5, 6, 7, 8. 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. Now I'm going to write my first set of statement. 3 medium pizzas gives you any statements you want to write. It is perfectly fine as long as it reflects what is in your diagram and helps you to monitor your progress while you're doing your problem solving. 24 slices. Let's draw some more diagrams. I know 24 plus 8. And you can also add 2 as well for students who are a little bit below the multiplication and division standards. Whatever works for you, as long as you get the answer. All right. So I can add 24 plus 8 will give me 32. Plus 8 will give me 40. I know that I'm not over the 42 as yet, so I can go ahead and put in my slices now. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. 1, 2, 3, 4, 5, 6, 7, 8. I know 3 more. Three more medium pizzas. Let's count them. And I know what you're saying now. How Miss went over the 42 and I realized that. But let's see. 24 plus 8, 32, plus 8, 40, plus 8, 48. Because if we do write another here, to say 3 more medium pizzas, which will give us 6 medium pizzas, gives you, and we know that 3 and 3 gives you 6. So 24 and 24 will give you 48, right? 48 slices of pizza. Now let's see if Miss went wrong. Even though the class has 42 students, and this is something that we must pay attention to, and we will stop at 42 slices here. So when we're here, this is 24, 32, 40. We cannot buy 40 slices of pizza or 5 medium pizza because 2 students will be left without pizza. Do you follow? We can further do this here. We can do it like this, 8 slices. 16 slices and so on. I can do that labeling afterwards. But when we're here now with our 40 slices, right? 40 slices. We can't just say, oh, 2 persons didn't get any pizza. Them lucky. No. We have to buy another pizza, and whatever we want to do with the remaining 6 slices, we can do that. So whether we want to give somebody else another slice or we want to toss it in the bin, we can do that, but we must buy another pizza so that we can get the 2 slices from this additional pizza. So in total, we will definitely need 6 medium pizzas. I hope we're all still following. All right. So even though 48 slices will be for 6 pizzas, we have to buy that additional pizza so we can get the 2 slices. All right. Let's go back to my document and I'm gonna start shading in for the medium pizza. So we need 6 medium pizzas. Now for the large pizza, going back to my whiteboard. For the large pizza, and with my title, the large size, and I'll put, we need, you realize the statements can vary. We need dash large pizzas to serve a class. All right, now let's draw our large pizzas. One large pizza. I know the pizzas don't look any much larger than what I had them to be before, but the space. All right. So I have 3 large pizzas. Now the large pizzas have 10 slices each. Let me go for my slicer. 1, 2 slice. 4 slices. 6 slices. 8 slices. If I can get another slice here in. It's 10 slices. This is an unproportionate pizza. Let's count. 1, 2, 3, 4, 5. And if you realize I count half of the circle or the semicircle, so I know that there's 5 at the bottom. Let's get our slices in. 1, 2, 3, 4, 5, 6, 7, 8, 10 slices. 1, 2, My pizzas are getting very messy. Six slices. 8 slices. And then let me get my 10 slices. So I know 10 times 3 are, I could just count them, are 10 plus 10 plus 10. 3 large pizzas will give me 30 slices. 3 large pizzas will give us 30 slices. Get another large pizza in. One more large pizza. That's 40 slices. One large, another large pizza. That's 50 slices. Again, Miss did not go wrong. Because 4 large pizza will only give us 40 slices. And we cannot exclude the 2 students that need pizza, right? So even though there are going to be 8 slices left behind from the additional pizza that is bought, we have to buy 5 large pizzas, sorry. We have to buy 5 large pizzas. So the students who did not get from the 4 large pizzas, because that would have only been 40 slices, they will get this additional 2 slices from the 5th pizza. Right, so we still need to give them 2 more, even though 8 is left behind, right? So far we have 10 slices, 20 slices, 30 slices, 40 slices, and we have to have 1, 2, 42 slices. So in all, we need 5 large pizzas. Will serve 42 students. Whatever we want to do with the remaining 8 slices, we can, but we must buy another pizza. Can't just tell them that, oh, the pizza done, to buy another 5 large pizzas. Go ahead and say before I even go to my document. So we need 5 large pizzas. For our extra large pizza now, we have 12 slices for the extra large pizza. So I'm gonna start drawing my extra large pizzas again with my title, the extra large pizzas. One extra large, 2 extra large. See, these looks really extra large. 3 extra large. Let me hold off on the other extra larges. Those are in the oven baking. All right. We will need dash extra large pizzas to serve the, it's gonna go over. I'm just gonna put extra large piece. All right, let's Go ahead and slice up our pizza. 2, 4, 6, 8, 10, 12. 12 slices, 2, 4, 6, 8, 10, 12. 2, and we have enough time in the test. We can afford to do it like this. We don't want to make any mistakes, and we really want to utilize the problem solving process. I think I have 8 slices here, and then I can get my 10 slice and 12 slices. So 12 plus 12, 24, plus 12, 36. 3 extra large pizza. Pizzas will give us 36 slices. Let's see. So we're just gonna try another extra large pizza. One slice, or 2 slices, 4, 6, 8, 10, 12, 12. So if we add another 12 slice, like 4 extra large pizzas will serve or will give us. So we can add 12 to 36, that will give us 48. And again, students, we will have extra slices, but we need the additional 2 slices. All right. So when we have 36 slices here, 36, 37, 38, 39, 40, 41, 42, right? So we'll have some of the slices remaining, right? But we still need to buy an additional pizza because we don't know any pizza that just comes with 2 slices. So we have to buy an additional pizza altogether to get the amount of pizza we need. So we need 4 extra large pizza to get 42 slices. I hope we're all on the same page. So we need 4 extra large pizza. To get that 42 slice of pizza for the students. All right, so let's move on to part 2. Now, part 2 has to do with the amount of juice needed. The objective for this question is to solve worded problems using one or two basic operations. In this question, we are going to be also looking at the same real life mathematical problem, which will help us to identify the relevant quantities important to determine the minimum amount of juice needed for the party. And why I really had to stick to the problem solving process is that it gives us an insight into real life problems. These are situations that we can presume that we can experience in our real life. And as such, we can make the association with problem solving in our classroom and use the process to help us to solve these real life problems. So a parent donated 50 cups of juice. Each cup of juice can hold 500 milliliters of juice. Question 3 asks us, what is the least amount of juice needed if each student will receive 1 cup filled with juice? And use our working notes. We can use this space to show our working notes. So what we should pay attention to is, again, the 42 students, right? If we have 42 students, and each student must get a cup of juice, because that was what was told to us initially, then we can say, if each cup can hold 500 milliliters of juice, we can multiply the 42 times 500. Two times 0, 0. 2 multiplied by 0, 0. 2 multiplied by 5, 10. We'll put our 0 here for placeholder. 4 multiplied by 0, 0. 4 multiplied by 0, 0. 4 multiplied by 5, 20. We put our addition and draw the line. 0 plus 0, 0. 0 plus 0, 0. 0 plus 0, 0. 0 plus 1, 1. 2 plus nothing, 2. So we'll get 21,000 milliliters, other units of measurement. So the least amount of juice needed if each student will receive 1 cup filled with juice is 21,000 milliliters of juice. And we can just always write our statement here. The least amount of juice needed is 21,000 milliliters. Again, full marks there. Move on to number 4. It says, based on your answer to question 3, how many 2-liter bottle of juice should be purchased for the party? How many 2 liters bottles of juice will be purchased for the party. So we have a conversion here to say that 1,000 milliliters will give us 1 liter. So we can do 2 routes of finding this answer. We can either find out how many 1 liters of juice we can get out of the 21,000, or we can just go ahead and we can find out how many 1 liters of juice we can get out of or 1 liter bottles of juice we can get out of the 21,000 milliliters of juice and divide that by 2, or we can go straight ahead to find out how many 2 liter bottles of juice we can get out of the total amount of juice that would be needed for the class. All right. So here in this question, we're going to be using, this is from the measurement strand. This question is from the measurement strand, and we're going to be using or choosing and using the most appropriate metric unit and their abbreviation in a given measurement situation. In this question, we're going to be required to interpret the results to a previous question based on the context given by determining the number of 2 liter bottles of juices that should be purchased for the party. So again, we can use 2 routes, right? And just for demonstration purposes, I'm going to do both of the routes and then separate it by this line. So we know that the total amount of juice is 21,000 milliliters. So we'll put our 21,000 here. Make sure that we affix our unit of measurement. I'm going to also put 21,000 over here. Milliliters. So some of us work very basic, while some of us can work advanced. For the students who can work advanced, they can go ahead and find how many 2 liter bottles of juices can be purchased for the party just by looking at it and dividing it. Others might have to do 1 liters first and then they divide it. So we can divide it here. I'm going to use the divisions. So we can, but we know that 1 liter measures 1,000. So we can divide this here by 1,000 to get how much 1 liter bottles we can get. And we know that 1,000 into 21,000, we can just cross off the zeros here. 1 into 21, 21. So we'll have 21 1 liter bottles. For everything, we must write our description. 21, just to keep our focus and try to monitor where we are. 21 1 liter bottles. This is American, so it's giving me incorrect, but it's okay, right? And then this 21 now, we can further divide it by 2. Right? And that will give us how many 2 liters. I won't write that down as yet because I want to do it here first. So we know that 1 liter is 1,000, so 2 liter will be 2,000. As 2 times 1,000 is 2,000. So we can say that 2,000 into 2,100, we have to put it into the fourth number because it cannot go into either of these numbers here at the front. Cannot go into 2, cannot go into 21, cannot go into 201. So we have to put it into 2,100. 1 time. 1 multiplied by 2,000 will give us 2,000. draw a line here. This is long division, by the way. Just fix up my 2 here. 0 from 0, 0. 0 from 0, 0. 0 from 1 gives us back the 1. And I don't want to put a 0 in front here, so I'm just going to put a dot because 2 from 2 will give me 0, but I'll put a dot there to show me that it's 0, not to confuse me. And then I'll bring down my 0 here. 2,000 to 1,000, you cannot go. So that goes 0 times 2,000 to 1,000, 0. 0 multiplied by 2,000 gives us back 0. And the long division will take us down a couple tiers. 0 from 0. Nothing from 0, 0. Nothing from 0, 0. Nothing from 1 give us back the 1. Right? 2,000 into 1,000 again, we already did that and we saw that it was 0, so we know that it cannot go in there. So we're gonna put a decimal place here, and then we're gonna borrow a 0. We have to put a decimal place here to show that we're borrowing this 0, and it's actually less than 1. Now, 2,000 into 10,000 will go 5 times, and 5 times 2,000 is 10,000. So we got 10.5. And we know this is complete here, so we can just that's here. So now we can just check back over here. 2 divided into 21. 22, 1 time, 2 ones, 2. This is now a little mini division still. Forgot my multiplication and my subtraction sign there. Bring down our 1. Let me bring down my text box. All right, let's say up. And we know that 2 from 2 will give us nothing. 2 into 1, 0 times 2 times 0, or 0 times 2 will give us 0. Still have to do a little long division here, but it's very much simpler than what we're doing over here. 0 from 1 give us back 1. We already did it before and see that 2 into 1 doesn't go, or it cannot go. So we'll put a decimal sign and borrow a 0. 2 into 10, 5. 5 times 2, 10. And we're done there. So that would have been the working out. So we can use it either way, right? Still gives us the answer that we would need. No, this is the tricky part. Remember, just like how we were purchasing the pizzas, and when we purchased 4 of the large pizzas, we got 40 slices because there were 10 slices each. We needed an additional box of pizza. And even though it would give us 60 slices, we still needed that 2 slices from the additional box, right? Similarly here, 10.5 means 10 and a half. No, I'm sure none of you have ever seen a half bottle of juice being sold. Yes? So we need to purchase another bottle. We cannot purchase 10 bottles because we still need 500 milliliters or half a liter of juice for the remaining students. So we have to purchase an additional bottle. So in total, we need 11 bottles, 11 2-liter. I'll put it in word, 11 2-liter bottles of juice. So we need 11 2-liter bottles of juice for the party. Let's move on to the next question. Now, this is the final part of this mathematics performance task. We're still within the time frame to complete our task. This part has to do with the total cost of pizza and juice. This question goes back to the number strand. And the objective of this question is also to solve worded problem using one or two basic operations. In this problem, we're going to be required to make a sense of a problem by analyzing constraints given in order to choose an option based on the total cost, which is within budget. So the scenario reads, you are given a budget of $9,500 to buy the pizza and the juice from Amazing Pizza. Use Amazing Pizza's price list shown below and your answer to question 4 to determine the total cost of pizza and juice needed for the party. Stay within the budget. So the cost for the sizes of pizza from Amazing Pizza are, for the small pizza, that's $1,100. For the medium pizza, $1,600. For the large pizza, $1,800. And for the extra large pizza, it's $2,000. And the 2-liter juice is for $200. You must consider the following. Each student must get at least one slice of pizza. You may purchase pizzas of different sizes. For any 3 pizzas bought, you get 1 2-liter bottle of juice free. Question 5 says, what is the total cost pizza and juice? What is the total cost of pizza and juice you would purchase to stay within budget? And we're going to be supporting our answer by showing our working out. Let me go back to the price list. All right. So based on my working out in part 1, I knew that 3 large pizzas will give me 30 slices. So I'm going to go ahead and purchase 3 large pizzas first. So I'm going to say 3 large. I'm going to put an acronym for large. Pizza. Pizzas. 3 large pizzas equal to One is 1,800 or 1,800. So I can multiply that by 3. Three times 0, 0. 3 times 0, 0. 3 times 3, 24. Put my 4 down at the bottom, 2 at the top. 3 times 1, 3 plus 2, 5. So the 3 large pizzas I bought was 5,400. Because I'm staying in my budget, what I need to do immediately is to subtract this 5,400 from my 9,500 to see how much money I have left. So that's what I'm going to be doing. And I can just put a little note to say that the budget is 0 from 0, 0, 0 from 0, 0, 4 from 5, 1, 5 from 9, 4. So I have $4,100 left. And I already have 30 slices. Right, do my statements here. 3 large pizzas equal 30 slices. All right, writing it like that so I can just keep on track of what I'm doing. So I have $4,100 left. Let me go back up to my price list. So far I need 12 slices of pizza. Right, I don't need to purchase anything over. I can either buy a extra large pizza with 12 slices for $2,000, or I can buy 2 small pizza with the same 12 slices for $2,200 because I'm doubling this 1,100. I'm gonna stay on the safer side and buy 1 extra large pizza for $2,000. I'm gonna buy 1 extra large pizza equal 12 slices. So if I buy 1 extra large pizza and 3 large pizza, I have 42 slices. There's also something that I need to take into consideration. Because I bought 3 pizzas, I get a free juice. I got 1 2-liter juice already. I have 1 2-liter juice. Let me just put that over this side. That's what I'm calculating my juice over that. All right. So let me see how much was the extra large pizza now. Let me subtract that extra large pizza from the remaining budget that I have. $2,000. So I subtract my $2,000 from 4,100. I'll have $2,100 left. Still in budget. Money don't done yet. So now I can say that all my pizzas are bought because I have enough slices for 42 students. Now with the $2,100 now I can do the remaining juices. So I know that I was going to buy 11 2-liter juices based on what I calculated initially. And I know that I got one free already. I don't need, let's put one here. So 2-liter juice free. So now I can calculate how much would it be for 10 2-liter juices, right? Because I already have one free. So for 10 2-liter juices, the 2-liter juice is for $200. And 10 of those would be $2,000. Literally, I'm in budget. I only have like $100 left. 0 times 0, 0. 0 times 2, 0. 0 for placeholder. 1, 0, 0. 1, 0, 0. 1 times 2. 2. I'm literally just $100 in my budget. So I'll take away this $2,000 I just spent from the juice, from what is my total budget, and I have $100, measly $100 left. That's all I have left. But I'm still in budget, right? So I got my 42 slices by 3 large pizza and 1 extra large pizza. And then I got 1 juice free, and then I bought 10 juice. I can say 10 2-liter juices is $2,000. And I could just add it to say that here that 3 large pizzas cost $5,400. And I knew that plus 1 extra large pizza cost $2,000. And I can just do a rough check to check it back to see if I'm still in my budget. That's what we do with problem solving. We look back over at our answer. So 5,400 plus 2,000, that's 7,400. Plus another 2,000 for the juice, which will give me 9,400. $100 left within my budget. So I'm still fine. And I would have gotten a total mark or the full marks for this question because I did everything down to the T with my statements, my working out, and everything to support my answer. So there you have it, students. And I still would have had some more time left in my examination, even though I did the long way of drawing all the pizzas. Yes, I'm extra. Like the extra slice or the extra large pizza. So there you have it, students. That's the Mathematics 2019 past paper. This should give you just an insight of what the past paper or what the current paper will look like, the structure of it. Clearly, there are going to be different questions. The teacher's activity, like what I explained for the science performance task video that I'll be looking at, will give you the actual topic that will come on the examination. It will not give you the examination paper. Please, people, don't ask me for the paper. I don't work at the ministry and I do not have the papers as yet. What I do have is the teacher's activity, and that will give you an insight to the topic that will come on the examination. The teacher's activity were given to the teachers who are administering the grade 5 performance task to prep their students for the performance task. While some of our teachers will be ahead of time and will already do that prep, some of our teachers will wait till tomorrow or probably early next week. I'm going to be doing that video today. Yes. So if you are on the channel, you're ahead, right? And you know how to stay ahead. So subscribe to the channel, refer your fellow classmates, your cousins, your brothers, your uncles, your uncle who has a child that's doing PEP. Yes. And everyone, let them know about the website. Click the notification bell so as soon as a new video is released on the channel, you know, and you know. So head on over and come and get the insight that Miss Bowen always shares with you. All right? Until next time, I wish you all the best in your examinations next week. Stay tuned for the social studies past paper and the language arts past paper, and for the teacher's activities for all the 4 subjects. You do not want to miss it.